So pointer you could capture. ठीक है. So कौन सी slide? So last class we devoted the whole time of the class on understanding the plane that you see in a tetrahedron. So in a tetrahedron you can imagine 6 planes, and in a octahedron, sorry, in tetrahedron, so you can write it if you imagine a molecule adopting a tetrahedron geometry and number them in this such way you can describe the planes. The plane contains which are what are the points that is contained within the plane, and what are the lines that it cuts through. So we do not say it cuts a bond. If we say it cuts a line, that is okay. That is always valid. Bond may be there, may not be there in case-to-case basis, but you can always draw a line in the imaginary line while describing that geometry. So this is the 3 C2 axis that is being shown in this special case. 1, 2, and third one this you can so this is easy to visualize. When to visualize the C2 axis in a tetrahedron geometry becomes easier when you see it as a special case. See it derived from the cube. So we visualize it as having a top from the top face of the cube to the bottom face. So you see bottom face of the cube and the top face of the cube. Running along the diagonal you have two atoms, and running along the other diagonal of the opposite face, which is the diagonal is not aligned, it is also crisscross type of thing, that is you can see face to face, and put the two atoms and one atom is going to the center. Simple. This is your tetrahedron inscribed in a cube, or you can see say it as a cube tetrahedron being derived from a this thing cube like structure. So C2 axis is easy to define from face to face, center of each face, one face to the other. It is coming out, so you can see one C2 axis going across another. So face on the left hand side to the right hand side, bottom face to the top face, center to center. So these are the C2 axis that you can easily visualize. Similarly, you had a lot of in the same way we were also trying to have a understanding of the planes that we can have in octahedron geometry. So keeping this in mind, we designed this thing, and I showed you that website simotter.org. So use that website. That is good for understanding things because you can get a three-dimensional view. And then we move to this other symmetry elements that have not yet been discussed thoroughly. So inversion center. Inversion center is a point. It is center of the system that you can describe. It is a point through which you move the object from one side to the other side, crossing that point. Okay. So so again so in this is a molecule which it is a ethane. You can see it, and ethane can have several conformations, and this is the staggered conformation that we are talking about. And the staggered conformation, it has this kind of center of, there is a point which is you can see it is has an inversion center, because so this arrow shows that you can if this is the point, you put it through. Imagine a three-dimensional geometry. So it is above the plane, going through this point, goes to this point, goes cutting, goes through, passing through that central point, this hydrogen atom, and so on, and similarly for the other one. So this is the way we can talk about the geometry. So this is this example is, it is the inversion center, the center that we were discussing was in space. It can also lie on an atom, but as we see, so it is, so it has to uh, so if it is in space, then all atoms must be in even number. So we can see in this case. And if it is the point lies on an atom, then other atoms should be in pairs, and it will be an odd number. That particular atom would be presented as an odd number. So this is the example of a the in which the center is an atom, like SF6 ML6 that you can think of. ठीक है. और इन्वर्जन का मतलब जैसा बताया कि वन across the point, move it across the point, go to 6. So 6 1 goes in place of 6, and 1, so 1 is here and 6 comes in place of that. So the interchange of the places across this thing. So this is the inversion. Invert karna, invert, the word is invert. The verb that you see, the we are carrying out inversion, or we are inverting the points to so this is a thing that we are doing across to the other point. And then related to this, the last one is the improper rotation. Improper rotation is something that is combination of reflection and rotation together. So it is, you can visualize it to be having a carrying out a reflection, and then in the perpendicular plane you can rotate, or vice versa. You can do both the things in any order, and in some molecules you will find that the geometry remains unchanged. So this is slightly difficult to visualize because it involves two steps, and together they are called this is called improper axis or improper rotation. So look at this. This is a CH4. So you perform C4. So this is the axis. If you imagine this as an axis, perform C4 rotation along this. So when you perform rotation by 90 degree, what will happen? This A, which is in the plane, आपके screen के plane में है, B is in the plane of the screen. Okay, so when you rotate 90 degree, what will happen? A will come in front of the screen, and B will go back. Okay, what will happen to D and C and D? C and D, C is so when you C is in the front, D is behind the plane, behind the screen, right? So behind the screen is D, front is C. So 90 degree in this way, the way we have considered, D will come in the plane, C will also come in the plane, because from behind of the screen it will come into the plane of the screen. C will from the front of the screen, C will go will also come into the screen. So D and C come in the plane of the screen, and A and B, as I told you, A is coming in the front of the screen. So imagine you are rotating this structure. A is coming in the front, B is going in the back. So this is a 90-degree rotation that you can imagine. And imagine now you have you do a mirror operation. So at this from the central point, this atom, you imagine a plane. So this is the sigma h, the perpendicular. So this perpendicular to this axis, I am visualizing a plane and performing the rotation. So that is C4, and then sigma h, this operation. So perpendicular to the axis, we call it sigma h. So when you perform this operation, so A and B will come to this side, left hand side of this uh, sigma h plane. So A and B here, and D and C go there. So this is now the appearance of this is unchanged. If you compare these two, they look the same way. They appear as the same, almost the same. So this is appearance is unchanged. So this is example of a CH4 molecule having so this combination of C4 and sigma H is called S4. Improper rotation, improper axis, and the operation that, so this is the symmetry element named is this element, and the name of the operation is improper rotation. So this is the same thing. Improper rotation is the name of the uh, operation that we carry out. Okay, so overall name. So this is what we mean by improper rotation. So CH4 molecule uh, has improper axis of rotation, which is this. So this is again a visualization of the same thing. So rotation by 90 degree, and then reflection through this plane. So 1 2, so I told you if you are drawing on a board how to draw it. So the solid line you draw for the something atoms that are in plane, showing the bonds that is in plane, and the showing the bond that is coming out of the screen, you draw this wedge type line. This is called wedge type line, right? Wedge type wedge type line. And this is the dotted line or dashed line that you can see. So this is the dotted line for something to be behind the screen. We show it like this. So this is a way to how you can draw a 3D geometry on this kind of two-dimensional plane, showing the bonds, location of the bonds, how they are. So 90-degree rotation, H coming, so this is the reverse way we are rotating this time. So H is going behind the plane, one is coming in front. See, front of the plane, front of the screen, back. So ये उल्टे डायरेक्शन में रोटेशन दिखाया गया है ना. And again perform the reflection through this thing. So this goes here, this will go here, and this will go here. So you have 3 4 over here, 2 1 coming over here. So this is how you get, or in one set we say that simply that we have performed the improper rotation, and it will look like this. So this improper axis is present in staggered conformation of this is an S6 axis present in C2 this C2H6 molecule, the ethane. So you can visualize this as taking place in this manner. You can write staggered ethane. So you can see this. This is a visualization of uh, the system that if carbon-carbon bonds, you are viewing one bond carbon is in front of the screen and another carbon is behind the screen in a straight line fashion. So you connect the dots. So this is the one that is the front carbon. So this is a way to represent the structure, and behind it, so you have three bonds. What happened? Something got wrong. So this is one way to represent it. So now S6 rotation means rotation by 60 degree. First you rotate by 60 degree and then reflect it. You can also do the opposite, reflection then rotation. In both cases the result would be the same. So let's just try one thing and see. So C6 rotation. So this is the view of the thing. So this is axis, that is, so if we are viewing it in this way, it is placed in front. So the red dot indicates that the axis C6 is coming out of the screen. Okay, so you rotate by 60 degree, what will happen? 60 degree rotation you perform, H1, yeah, so H1 will come in place of so it is, so remember this is the, this angle is 120, and so 60 degree rotation means H1 will be somewhere. If it is a clockwise rotation, what will happen? Clockwise rotation होगा ऐसे. So यहाँ पे नहीं, ऊपर से दिखा दे, ऐसे clockwise रोटेट करो तो क्या होगा? H1 यहाँ पे आ जाएगा, ठीक है, 60 डिग्री रोटेशन होने पे. ये पूरा एंगल 120 का है, तो आधा मतलब यहाँ पे कहीं आएगा. सो देखो, जो अगला हम स्ट्रक्चर ड्रॉ करेंगे उसमें H1 यहाँ पे आ गया. इसी तरह से H2 will come somewhere here. So you see it is drawn over here. फिर H3 को देखो तो यहाँ आ जाएगा. सो कुल मिला के आपका ऐसा होगा H1 H2 H3 रोटेशन. पीछे वाले एटम कार्बन पे जो हाइड्रोजन है, so you have hydrogens attached to the carbon that is behind the screen. So you also perform, look at them, what you have to do. So when H5 is rotated in a clockwise manner, H5, it will come here, somewhere here from the back side. So see H5, and then you look at the other atom H4 and H3, perform in a similar fashion. So H4 will come in 60 degree. So you can imagine from behind the screen, if these atoms are conducted by 120 degree angle in this manner, so 60 degree means somewhere here. So जहाँ पे ये आपको H2 दिख रहा था वहाँ पे H4 आ जाएगा पीछे से, पीछे वाले कार्बन से. देखिए आपको एग्जैक्टली इस तरह से बनता जा रहा है, समझ रहे हैं? So this is a C6 operation, which itself is not a symmetry operation in case of ethane, but combination of C6 plus sigma. Now you reflect it in a perpendicular plane. So reflection through a perpendicular plane. So what will happen? जो फ्रंट में दिख रहा है वो वाला सब पीछे चला जाएगा, ठीक है, बीच में स्क्रीन आएगा. मतलब आपका जो, मैंने कहा कि कार्बन आपके सामने है, स्क्रीन की सीसी बॉन्ड्स वाली जो लाइन है वो स्क्रीन के अक्रॉस जा रही है, आर पार. तो दूसरा कार्बन एटम पीछे है, ऐसे विजुलाइज कीजिए. और अब आप उसको जब हम रिफ्लेक्शन करेंगे, यस, आप अभी ये जो प्रोजेक्शन है ये आपने 11th 12th में भी पढ़ा होगा. इसका मतलब क्या है? कार्बन जो बाहर की तरफ है, कार्बन कार्बन बॉन्ड एक बाहर स्क्रीन पे हमें दिखाना है, तो एक कार्बन बाहर होगा, एक कार्बन पीछे की तरफ होगा, ठीक है. वन कार्बन इज इन द फ्रंट ऑफ द स्क्रीन, अनदर कार्बन इज बिहाइंड द स्क्रीन, ठीक है. एंड दीज टू कार्बन्स आर कनेक्टेड बाय द बॉन्ड, ठीक है, स्ट्रेट लाइन, ठीक है, वो एक बॉन्ड हो गया. फ्रंट कार्बन is now connected to three hydrogen atoms through bonds. So this is the three bonds for the front carbons, ठीक है, फ्रंट में जो कार्बन एटम है. बिहाइंड दिस वी हैव अनदर कार्बन, और उसके साथ भी तीन हाइड्रोजन जुड़े हुए हैं. सो वी आर शोइंग 3 4 and 5. This 3 4 and 5 is to show the carbon that is behind this screen. and hydrogen atoms are connected to it. ठीक है, उस तरह से हो गया विजुअलाइजेशन कंप्लीट। पहला वाला पिक्चर विजुअलाइज कर लिया, इसको विजुअलाइज आपने कर लिया। अब आप ऑपरेशन परफॉर्म कीजिए। नाउ यू स्टार्ट परफॉर्मिंग द ऑपरेशन एज आई से। So now I said that you perform C6 operation, that means 60 degree rotation. Rotate it by 60 degree and इसको आप clockwise manner में ऐसे घुमाइए, easy है। तो clockwise manner में घुमाएंगे तो कैसे, कौन कहाँ पे जाएगा, आप how will you show the positions? So how to understand this point? So you must realize that when we are talking about this particular angle between H1 H2 or H2 H3 is that of 120 degrees, ठीक है। सो जब मैं 60 डिग्री रोटेशन कर रहा हूँ तो H1 जो है मूव करके ऐसे करेंगे तो ये यहाँ कहीं पे आएगा, समवेयर हियर। सो दिस इज व्हाट वी हैव टू शो, द फ्रंट कार्बन स्ट्रेट लाइन डायरेक्ट पूरा सॉलिड लाइन दिखाएंगे और यहाँ पे H1 दिखाएंगे। The same way you go on applying to other, pick the second carbon H2। अब ये 60 डिग्री ये भी मूव करेगा, 60 डिग्री रोटेशन मीन्स it will come here, so the bonds you show by solid line here coming over here like this, ठीक है यहाँ पे, and so the H3 will move to somewhere between। so थोड़ा सा प्रैक्टिस के साथ आपको समझ में आने लगेगा कि जो पीछे वाला है उसके बराबर में फ्रंट वाली लाइन को करना है मूव, ठीक है। इसी तरह से आप ध्यान से देखेंगे कि बाकियों को मूव करना है। अब H3 H4 H5 will also have to be rotated like that। So H3 will be by 60 degree rotations means, so H5, if you are looking at it, H5 and H3, this is 120 degree, so half of it means here, so you see you show it by here। तो ये पीछे वाला प्लेन है इसलिए वो बस पीछे का हिस्सा छुपा हुआ है, इसलिए हमने बस ऐसे हल्का सा दिखाया यहाँ पे। इसी तरह से you go to the other point, H5 H4 and again draw it in the same way, 60 डिग्री मूव करो थोड़ा थोड़ा, ठीक है ना। 60 डिग्री मूव करके यहाँ पे आ गए। अब जो है what we say in improper rotation, what we do in improper rotation is that reflection should be performed in the perpendicular plane। perpendicular to what? The axis of rotation जो अभी था उसके perpendicular। so axis of rotation is this line cutting across my screen, ठीक है ना। स्क्रीन के आर पार जो लाइन जा रही है वो मेरा रोटेशन एक्सिस था। डॉट के अगर मैं यहाँ पे डॉट ड्रॉ करूँ, सो दिस वाज माय स्क्रीन, तो स्क्रीन इज माय एक्चुअली द मिरर प्लेन। सो अब हम ध्यान से देखें तो एक कार्बन मेरा फ्रंट में है, एक कार्बन बिहाइंड द स्क्रीन है और अब मैं रिफ्लेक्शन कर रहा हूँ। सो व्हाट विल हैपन नाउ, जो सिचुएशन यहाँ पे H1 H2 H5 का था ये पूरा का पूरा पीछे, सॉरी H1 H2 H3 था, ये पूरा पीछे चला जाएगा। सो देखिए H1 H2 H3 पीछे चला गया और जो पीछे था H4 H5 H6 पीछे वाला ये सामने आ जाएगा। सो देखिए सामने दिखा रहे हैं H4 H5 H6। so this picture and this thing is appearance remains unchanged when we look at it। so this is this is a symmetry operation। so if you look at it in these terms, there is no such sigma plane exist in staggered ethane, there is no such C6 axis present in independently। so the C6 rotation is not a symmetry operation for ethane। sigma, the way we have visualized between two carbon atoms, is not a symmetry operation in a ethane, but the combination of the two, rotation by 60 degree and performing this thing, reflection by in the perpendicular plane, is indeed a symmetry operation। so combination of the two, and this is what we call improper rotation, and this is identified as a symmetry element that and we perform this thing। so you can try this thing in the reverse way, you perform the reflection first and then do the rotation, then also you will get the same result। ठीक है. So this is another same thing, points to be. So this is another way to draw the picture. If you are reading the FA Cotton, they have drawn pictures like this for the same thing, 1 2 3 4 5 6. It is way to visualize the atoms positioned. So whichever way you can put it, you will get the same result. So either you can draw it this way, the way, or whichever we find is easy. So C6, then sigma, sigma, then C6, both resulting in same configuration, which is 1 and 4 are equivalent. 1 and 3 are not equivalent, 1 and 2 are not equivalent, but 1 and 4 are equivalent. ठीक है. And so this is a symmetry operation. Combination of the two is a symmetry operation. So इसमें भी आप थोड़ा उसी तरह से विजुलाइज कर सकते हैं. ये एक कार्बन है, ये दूसरा कार्बन है, ये सीसी बॉन्ड हुआ. ठीक है. और अभी जो हमने किया था उसी को हम लेते हैं. पहले हमने रोटेशन किया था. So if I perform a clockwise rotation on this, पीछे वाला कार्बन 60 degree rotation, so it will come like this. The points will move to this position. 2 will come here, 60 degree rotation, because this angle is, as I so 120 degrees. So somewhere here I should get it. So 2 is coming here, 1 is coming somewhere here. So see, 1 here, 2 here, and 3 going over here. So like this it is making out. So this is what see what has happened. Similarly 4 5 6 is here. So when you are looking at it, ये बाहर वाला कार्बन है 4 5. So 4 will come here and 5 will come over here in between. So 4 5 and 6 will be here, something like so. This is over here sigma, and then you visualize a plane that is perpendicular to this axis of rotation, rotation axis. Then perpendicular to the rotation axis I can visualize a plane. So putting that plane in the middle, reflection of that. So 4 5 6 will go behind the plane. So this is here 4 5 and 6, and 1 2 3 come in the front. So that's how we have this. So this is a one visualization, or you can perform it the other way around. Reflection through the plane, the perpendicular plane, and then rotation. In both cases you will get the same result. I think if you will be, it will be much easier if you perform visualize in this way. Only one इसको visualize करना शायद आपके लिए ज़्यादा easy होगा. What we are plotting is that, yeah, front carbon like this and second carbon behind, show it by a circle, and then attachment of these things. Okay, so this way it might be easier for you. You can draw it this way and it becomes. तो इसमें बहुत आसान इसलिए हो जाता है कि सिंपल आपको H1 को यहाँ करना है, बाद में 60 डिग्री रोटेशन में H2 को यहाँ करते जाना है, जहाँ जहाँ पहले से पीछे वाला एटम था वहाँ पे उसकी पोजीशन में. So it is pretty easy to do it that way, and then perform the rotation. If you want to visualize this through that thing, we can also do that. So we'll have to go to the screen. कहाँ गया? Type cmotor.org gallery and you will get to the right thing. थोड़ा सा इंटरनेट स्लो हो गया है, पता नहीं. Okay, so we are here. So I was telling you about staggered ethane, ethane staggered, this one. Go to ethane, staggered ethane, दिख रहा है? ये है आपका staggered ethane. एक एक्लिप्स होता है ना, जब पिछला वाला हाइड्रोजन पीछे सेकेंड कार्बन पे जो हाइड्रोजन है और फ्रंट पे जो है दोनों अलाइन हो जाएंगे, वो एक्लिप्स कॉन्फ़िगरेशन हुआ. दिस इज द स्टैगर्ड कॉन्फ़िगरेशन, मोस्ट स्टेबल कॉन्फ़िगरेशन. यू सी, दिस इज योर मॉलिक्यूल. और जो पिक्चर आपने ड्रॉ किया है वो ये किया है, समझ रहे हो? ऐसे जो हमने यहाँ पे दिखाया, सी, ये जो हम ड्रॉ कर रहे थे, फाइंड द कोरिलेशन बिटवीन व्हाट वी आर डूइंग. H1 H2 H3 फ्रंट कार्बन, मैं कह रहा था ना कि फ्रंट में जो कार्बन आ रहा है उसके साथ जुड़ा हुआ है, इसको आप जो पीछे, सो सी, अब ये पिक्चर दिमाग में बैठा हुआ है, अभी तुरंत अब इसको देखो, मॉलिक्यूल को जो मैं दिखा रहा हूँ. हाँ, सो यही है, देख रहे हो ना? H1, ये ऊपर वाला H1 हो गया, H2 H3. ठीक है, अब इसको आप मूव करोगे, सो परफॉर्मिंग, so the what you have to do, you have to perform rotation along this axis and then reflection in the perpendicular plane जो उसमें दिखा है, perpendicular to this axis. So this is the axis, the green line that you see passing through CC atom. ठीक है, इसके along rotation करना है और reflection. So combination of these two is one, simple S6 improper rotation. ठीक है, so S6 operation when you try to perform this, एक मिनट, अच्छा ये कुछ और हो गया. पॉइंट ग्रुप क्लास इन्वर्जन ऑपरेशंस, S6 rotation, reflection. So there are two things that has happened. If you visualize this, rotation and then reflection. Let me change this axis. So what we were seeing here, ये थोड़ा, so when we are saying this, it is rotation by 60 and then reflection. So this is the visualization that you should have. ठीक है, so अब आप इसको समझ सकते हैं ना? ये जो दो कार्बन कार्बन है, फिर से एक बार करते हैं इसको reload. So this was the situation and now you have performed. Yes, so ये देख रहे हैं ना आप? So this was your initial things when you started. ठीक है, so 1 H1 H2 H3 क्लॉकवाइज में हमने ऊपर से नीचे सामने वाले को लेबल किया आपने, यही हमने यहाँ पे किया था. देखिए लेबलिंग वाज लाइक दिस, H1 H2 H3, H1 H2 H3, पीछे वाला H4 H5 H6 H3, सॉरी हाँ 3 4 5 6 4 5 6 लेवलिंग कर दिया and then you perform the operations that I told you. So rotation by 60 degree means it will go here. 60 degree rotation ये यहाँ पे आएगा somewhere here front में, and so that is what it means. And we did the same, okay, each of them, and then reflection. So this was the axis to be shown. So rotation along this, and then reflection along in the perpendicular. ठीक है, so यही हमने लिखा था वहाँ पे, और इसको रोटेट करके यहाँ पे लाए थे, बीच में जो यहाँ पे 60 degree rotation means it will be here, 60 degree rotation for this means it will be here, 60 degree rotation means it will be somewhere here. ठीक है, और same thing applies to the something is in behind, and that is what we shown by drawing something that is in behind, that we have shown already by drawing this bigger circle and then a small lines. So it's that is for the carbon, second carbon which is behind, and 3 hydrogen that is connected. So once you visualize that thing, it becomes easier. Okay, so this is the S6 axis that is present in improper axis, and methane we have already discussed. In case of methane there was C4 axis, although there is no uh, yeah, so it might be a situation in some molecules which do not have sigma h planes, that there might be a combination of sigma h and rotation plus sigma h might be a symmetry operation. Individually they may not exist sometime. If however किसी मॉलिक्यूल में अगर C4 एक्सिस भी है, सिग्मा एच भी है, तब तो वो पक्का कब उसमें एक सिमेट्री एक्सिस S4 होगा. लेकिन इस केस में जैसे कि आपने स्टैगर्ड इथेन के केस में देखा, देयर इज नो C6 एक्सिस, बट देयर इज अ S6 axis is present. A combination of C6 plus sigma H is there. Similarly, in case of methane, also you do not have a C4, you do not have a sigma H. There is no sigma H plane in a methane, but combination of sigma H and C4 is giving an equivalent structure, which is, so this is what we call improper rotation. So if you look at it, what we have done is that so simple. If you look at S1 rotation, so S1 rotation, what it means rotate by 360, rotate by S1 means 2 pi by 1, so it is rotate by 360 degree, and then reflect, or vice versa, reflect in perpendicular plane through a perpendicular plane. So whatever axis you have for rotation, rotate you. So S1 is what? So if you have a point initially over here, so you perform rotation. So 360 rotation, if the point is here, 360 rotation means it is coming back onto it, and then you are reflecting through the mirror plane which is perpendicular to this axis. So this is the axis C1, and then reflecting. So this is overall result is what? Simply it is reflection. So S1 axis is doesn't exist because it is the same as a mirror reflection. अगर हम ये 360 रोटेशन नहीं भी करते और सिर्फ एक प्लेन के थ्रू रोटेशन करते जो परपेंडिकुलर प्लेन में है, so that is equivalent of doing a mirror reflection operation simple. So S1 axis does not exist. The improper axis labeled S1, that is 360 rotation and reflection, does not exist because the meaning is same as doing a simple mirror operation, reflection doing reflection. So, and look at the S2 axis. If I say there is a S2 axis, what it means? Perform 180-degree rotation and then in the perpendicular plane reflect it. So it is from the point on 180-degree rotation comes here, and then reflection it is here after reflection. So second one step, second step, first step we rotate, second step we reflect it in the perpendicular plane, it is coming here. Now this result is exactly the same as performing a inversion. Inversion was you locate the center and through that central point one side to the other, take it to this other point. So this is the inversion operation. So s1 is equal to sigma, s2 is equal to I, and so s1 s2, these are the axes which is do not exist. We say that s1 s2 had independently अलग से कोई एक ऑपरेशन नहीं बन रहा है s1 s2 का, ठीक है. It is the same as one is equivalent to performing a reflection, simple reflection, another one is equivalent to doing inversion. So s1 s2 is do not exist. They are same as one of the defined symmetry elements earlier, ठीक है. इसी तरह से आपको improper rotations allenes, एलीन का एग्जाम्पल है. सो यू कैन सी दिस इज एन पिक्चर ऑफ एलीन. सो एन एलीन इज सेड टू हैव अ S4 एक्सिस. S4 एक्सिस मतलब एक इम्प्रॉपर एक्सिस है S4. मतलब इफ यू परफॉर्म रोटेशन बाय C4 rotation and in the perpendicular plane perform reflection, you should be getting the same structure which is comparable to itself. So एक थोड़ा सा नीचे कट रहा है क्या? अभी भी इच कट रहा है, ठीक है. एनीवे, so step 1 you perform C4. So you look at the alene. Alene will have, this is the structure, two hydrogens in the plane of the screen, other two hydrogen, one is behind the screen, this is behind, this is front, in the front of the screen. So wedge type line and dash type line, this is how you draw. Okay, so rotate C4. 90-degree rotation means this will go behind the plane, it will go behind, and the other two will, this will come is if it goes behind, this comes up in front, this will come in front, and similarly the H. So the something that was behind, if you rotate it by 60, it will come in, it will be like this. So when you perform one thing, it will be, this is the structure that you will get. Okay, ध्यान से देखिएगा. आप ये जो देखिए कैसे रोटेट हो रहा है, ऐसे रोटेट करना है, ठीक है. मॉलिक्यूल along this axis performing rotation like this. So this hydrogen goes, this hydrogen goes in the plane of paper like this, and another one comes like this. So these two are here. Now you choose a perpendicular mirror plane. So this was the axis of rotation perpendicular to this, this is the plane mirror, and now reflect it. So this comes over here, H, two hydrogens like this, and another two hydrogen over here. So the an S4 axis, improper axis S4 exists in case of, so improper rotation is a symmetry element for allenes. Similarly, you can think of this molecule which is having a C7 you can perform a C7 rotation, and then so this is not a planar structure. You can think this is hydrogen coming out of the screen. These three hydrogens are behind the screen. Only these two hydrogen are in the plane. So when you rotate by 2 pi by 7, then this is how this will look like, performing a perpendicular plane. So perpendicular plane means you have the screen as your plane. This is your C7 axis, and so perpendicular to this is the screen itself. So if you reflect it, it will come like this. C12 improper axis. In case of this molecule, you have chromium, then you have benzene ring, two benzene rings. So डाइक्रोमियम बेंजीन, ये आपको मैंने पहले बताया था, नहीं CR बॉन्ड था उसमें, वो अलग था। हाँ ये दूसरा है। हाँ, chromium, one chromium bound to attached to two benzene rings in this fashion. So in this case you have the structure is the, if you are viewing from the top, then it will look like this one, the front one, this one, and behind one, the blue, is like this. So you have a 2 pi by 12. If you rotate it along this axis, it will change. So this is imagination that you need to have a C12 axis. So 30-degree rotation you perform, and this will change only slightly like this, and the behind the blue line that you see, that is also changing its position. So then reflection through the plane. So reflection means you are in between this. So if red colored ring is in the front of the paper, front of the plane, front of the screen, the blue benzene ring is behind the screen. So rotation was performed in along this perpendicular axis. The axis is coming out of the screen, ठीक है? So the perpendicular plane means the screen itself. So you perform the reflection through that, then the back side one, the blue one, will come in front, so it will look like this. Okay, so when we perform reflection, the blue things which are at the back, that is reflected and comes in front, and so you have a that blue ring which was like this. The blue one was here like this. So this is what we are drawing, because red line is to indicate the front, so we are drawing it like this. So this is equivalent structure again. So this is the S12 operation. So these are the examples of ferrocene type molecules. So this is example of cyclopentadienyl Fe, and connected to two cyclopentadienyl anion C5H5 minus. So this is, so again staggered conditions are giving you typically this kind of thing. So whereas in many of the molecules where staggered conformation is possible, that conformation is leading to this thing. But in other cases where it is a single molecule, no, this like CH4 also, you are having the improper axis staggered. So okay, so when we have done this, we can, yeah. So after knowing all these things, you can we can classify. So you can look at some of the molecules with this kind of structure. That will, for practice, you can do a lot of practice on this also. The inversion centers and the improper inversion center भी आसान होता है, उसमें बहुत मुश्किल नहीं है. इम्प्रॉपर एक्सिस भी पहचानने में ही लोगों को दिक्कत होती है थोड़ा, वो जल्दी विजुलाइज नहीं होगा। फेरोसीन, let's look at the ferrocene. This is a ferrocene. This is staggered. Staggered, so you can perform. So what we were seeing there, ये जो हम एग्जांपल अभी दे रहे थे, कौन सा एग्जांपल था? ये वाला C10 एक्सिस, मतलब C10 C10 एक्सिस 2 पाई बाई 10, सो 360 बाई 10 मतलब 36 डिग्री का एंगल। So this is, if you, so in 3 dimension if you want to visualize this, ये रहा फेरोसिन, staggered condition of and so here you have the uh, S10. So this is the axis और ये perpendicular plane. So इसको फ्रंट में रख के यही ड्राइंग हम लोग कर रहे थे कि एक को रेड ड्रॉ कर रहे थे, एक को ब्लू ड्रॉ कर रहे थे, और पीछे वाले का हल्का हल्का वो ब्लू से लाइन दिख रहा था जो इसके ऊपर से। ठीक है, इसी तरह से ड्रॉ करते हैं हम लोग। एंड सो यू परफॉर्म द रोटेशन अलोंग दिस लाइन, ये जो सेंटर में अभी S10 वाली एक्सिस है, ठीक है। एंड देन सो यू so rotation and then reflection, ठीक है। but this is not the case for ferrocene eclipsed, is a different view। ferrocene eclipsed, दोनों ऊपर वाला रिंग और नीचे वाला रिंग एकदम एक दूसरे के ऊपर ऐसा दिखेगा, ऐसे रखेंगे वर्टिकली, दिस इज एक्लिप्स। सूर्य ग्रहण चंद्र ग्रहण कहते हैं ना एक्लिप्स, एक्लिप्स का मतलब बिल्कुल उसके एक के ऊपर एक आ जाना, आमने सामने आ जाना। सो पीछे वाली रिंग सामने और फ्रंट वाली रिंग दोनों एकदम आमने सामने एक के ऊपर, ठीक एक के ऊपर एक। सो दिस इज एक्लिप्स्ड, eclipsed view। So this doesn't have S10 operation possible in this case, however there is S5 operation that is you can do, ठीक है। C5 is axis is there। So this particular, okay, this molecule is an example where you have a C5 axis, C5 axis है ना। हाँ, अगर हम अलग से देखें, this is a C5 axis, this is C5, right? Rotation by 2 pi by 5 gives you a perfect you get a symmetrical thing, so that is a symmetry operation by itself। You also have a sigma h, you also have sigma h, perpendicular plane है ना, दोनों बाहर वाला और ऊपर वाला दोनों प्लेन्स, दोनों अगर रिंग एक दूसरे के ऊपर कोइंसाइड कर रहा है, इस केस में एक सिमेट्री प्लेन अपने आप में से ये है, ये दिस इज अ प्लेन ऑफ रिफ्लेक्शन, मिरर प्लेन है जो एग्जैक्टली एक के ऊपर इसको रिफ्लेक्ट करेगा। अब परफॉर्मिंग अ रिफ्लेक्शन गिव्स यू अ structure that is I that looks unchanged, that looks appearance is indistinguishable from the previous one, so that is also an operation individually। So combination of these two will also be a symmetry operation। So when we combine C5 and sigma, and combination of C5 and sigma is S5, so S5 is definitely a combination। So ऐसे molecules में जिसमें both are present individually as symmetry elements, a rotation axis, and in the perpendicular plane there is also a reflection possible, possible। So if they are alone, अकेले अकेले देखा जाए तब भी वो एक सिमेट्री एलिमेंट है, तो कंबाइन करने पे भी वो एक सिमेट्री ऑपरेशन रहेगा, और इस केस में हम S5 एक्सपेक्ट कर रहे हैं। लेकिन मुश्किल वहां पे होता है, जैसे कि ये फेरोसीन स्टैगर्ड वाला सिचुएशन था। देयर इज नो इंडिविजुअल C10 ऑपरेशन। C10 is not a symmetry operation by itself, but when we combine this C10 with reflection through a perpendicular plane, then it becomes a symmetry operation. So this is something, two symmetry elements which are initially individually not present, अकेले अकेले present नहीं है, लेकिन जब दोनों को हम कंबाइन करके व्यू करते हैं तो एक नया सिमेट्री ऑपरेशन निकलता है, दैट इज इम्प्रॉपर एक्सिस ऑफ S10। ठीक है, तो इस तरह की चीजें दोनों सिचुएशंस आपको एनालाइज करनी आनी चाहिए। सिमिलर यू विल बी हैविंग स्टैगर्ड इथेन, eclipsed ethane. So those situations you will be able to analyze. Benzene hexakis, डाइक्रोमियम बेंजीन कहाँ गया, डाई डाइबेंजीन क्रोमियम, एक डाइक्रोमियम बेंजीन है, एक डाइक्रो नहीं है इसमें। सो इस तरह के, अब CH4 वाला जो सिंपलेस्ट केस था उसका भी हम लोग डिस्कस करते हैं। मीथेन, मीथेन में आपको दिखा कि नहीं, LMN मीथेन, मीथेन का सिंपल एग्जांपल था। इसमें देखिए C3 इज एन इंडिविजुअली एग्जिस्ट एज अ C3 ऑपरेशन है, C2 ऑपरेशन एग्जिस्ट करता है, लेकिन कोई C4 ऑपरेशन नहीं है। A methane doesn't have a symmetry element called C4. C4 अकेले में individually C4 is not a symmetry operation for a methane, a tetrahedral molecule like methane. There is also no sigma H plane. There is no horizontal plane that we can talk about in a tetrahedron like this. But combination of the two is indeed a, this is the one, okay, C2 rotation by sorry C4 and a sigma perpendicular to that. This is an operation which is there, okay. So reflection, so these are the two things that you need to understand. So you, when you are looking at a molecule, this is becomes very tricky, that when some improper axis is there and you are not able to find out that is there any improper axis present in this molecule, yes or no, you have to see and find in this manner. So with practice you do more and more, you will be finding it easy later on. Yeah, so these are the, this was the example, and from here we will come to this point groups. So point groups, so we will be dividing. So if we find बहुत सारे मॉलिक्यूल्स को के सबके हम सारे सिमेट्री एलिमेंट्स निकालें, टेक वन एलिमेंट, find out all the symmetry elements present, take another element, find out all the symmetry elements present, and in this way we can have a set of symmetry elements for certain type of molecules. So in some cases 2-3 molecules may have same set of symmetry elements, एक जैसा ही सारा symmetry elements होता है जिस मॉलिक्यूल में, उसको हम एक ग्रुप कहते हैं कि ये these are having similar symmetry, same symmetry elements, 2-3 molecules. Then we say that this is we can categorize along due to based on the symmetry elements present, we can categorize into groups which is called point groups. Okay, so that we will discuss tomorrow. ठीक है. Meanwhile, you do some more practice with this, finding the improper axis, the example of ethane, the example of methane, and so many more examples that we have done. Try to see this. And yeah, ठीक है. So okay, so see you in the evening again regarding. ठीक है, so do some practice on this, and remember we can take a test on Saturday 10 to 11. ठीक है, आयनिक मॉर्निंग का एक टेस्ट हो. हाँ बोलो कौशिक, म्यूट है आप. आयनिक बॉन्डिंग, कोवेलेंट बॉन्डिंग हो गया, आयनिक बॉन्डिंग का हो जाएगा. हाँ मानक. वो जिंटल कंपाउंड, अच्छा जिंटल कंपाउंड का पीपीटी ही अलग है. ओ अच्छा, ठीक है मैं भेजता हूँ. ठीक है कर देता हूँ.